Okay, on the next several ones, it says in the formulas below, take the derivative with respect to time. And remember, time is not a variable we're using on any of these at all. So that means that we have to do the chain rule every single time with every single variable. Okay, so here we go. You ready? First one here is the area of a rectangle. So I'm going to find the derivative of the area of the rectangle with respect to time. And t is not our variable anywhere we go. And this is a product rule. Okay, so here we go. First is length times the derivative of the width. Well, the derivative of the width is going to be dw dt. Okay, plus, because this is product rule, the second, and the derivative of the length with respect to time. So this is interesting because now we have 5 unknowns. All right, so to solve for one of these, you would have to be told all of the other ones. All right, so this is an unknown amount. The length is an unknown amount. The rate in which the width is changing is an unknown amount. The width and the rate in which the length is changing. All those are unknown. All right, so there's 5 unknowns there. So we'd have to be told quite a bit. All right, so here we go. Next one, circumference of a circle. This is not a product rule because 2 and pi, that's a constant. So this is just constant multiple rule. And this is the radius is to the first power. So just like if you were to take the derivative of 5x, that would just be 5. So here we go. So the derivative of the circumference, that's capital C, with respect to time, t is our variable on all of these, is simply 2 pi, but again, that's not t. So the derivative of that would be 1, but dr dt. So just like every time we had a y when we were doing implicit differentiation, we had a dy dx. In this case, every time we have a variable at all that's not time, and that's all that we have, you will need a d, whatever that variable is, dt. All right, number 7, the volume of a cube. So the rate in which the volume is changing with respect to time, or dv dt, is equal to, power rule, 3s squared, but that's not t, so I need a chain rule, ds dt. We're going to be solving a bunch of these later on. Right now we're just getting used to this initial setup before we start substituting some stuff in. All right, one more before on this particular video, the lateral surface area of a cylinder. So we have d, it's like the can wrapper, if you will. ds dt is equal to, we've got a product rule. All right, we've got 2 variables. I'm going to keep those 2 together as the first. I'm going to have h be the second, and then away we go. All right, so I have first 2 pi r, and then the derivative of the second is dh dt. I think you're starting to see how this is rolling here. Plus the second, which I called h, times the derivative of the first, which would be 2 pi. And then r, of course, is going to go away with the derivative, but it was there, so I need a chain rule, dr dt. Look at that one. That's got all kinds of unknowns. Okay, cool. I'm going to pause right there, 5 through 8.